Hello everyone and welcome to EvolkAI, a machine learning community for machine learning enthusiasts. Now today we will be learning about Nearest Centroid classifier. So, Nearest Centroid is a simple and intuitive algorithm used in machine learning for classification. To understand it, let's imagine you have a group of friends and you want to predict whether a new person will like a certain type of music. In the nearest centroid algorithm, each friend represents a different category or class of music. For example, one friend might represent rock, another might represent pop, and so on. To make a prediction for new person, you measure the distance between the new person and each friend. This distance represents how similar or dissimilar the new person preferences are to each category. The centroid is like the average of central points of each category. It represents the typical preferences of friends in the category. By measuring the distance between the new person and each centroid, you can determine which category is the closest or most similar to the new person's preference. To make the preference, to make the prediction, you assign the new person to the category whose centroid is closest. In other words, you classify the new person based on the nearest centroid. So just look at this diagram, and by this, the nearest centroid algorithm is like asking your friends about their music preferences and classifying a new person based on their proximity to each friend's preference. By measuring the distance between the new person and the centroids of each category, you assign the new person to the category whose centroid is closest to the most similar one. Okay, so I hope you understand this. Now, moving to the practical part. Okay, so now first we will start by importing the pandas library, and we will read the data set using the read CSV function, and we will get all the data information using the info function. Then we will assign all the columns that we have to take from the user and store it in features variable, and the prediction class will be predicting column will be stored in prediction class variable. So and their values will be stored in x, and for the features, and for prediction class the values will be stored in y. X will have all the data that our user will give us as the input, and y that it will get as output from the machine learning model. Now this is the training and testing part. Here we have to train here we have to split the data into training and testing part. So here we have assigned test size as 0.30, which is an ideal, as we have already discussed in our earlier videos, that the testing part should always be less and training part should always be more. So here the training and testing part is divided into the ratio of 7 is to 3. That is 70% is the training part and 30% is the training part. More that a model will be trained, more accurately it will predict the results. Okay, so now here we will check the shapes of the data to check if the test split has done its work correctly or not. Okay, so now we have reached the most important part. Now from sklearn.neighbors library, we will import nearest centroid model and assign it to a classified CLF variable. Now we will fit this variable or this model with the training data, that is X train and Y train, and now we will predict the data on X test using the on the basis of this model and store the values in the Y print variable. Now from sklearn we will import metrics, and using the accuracy score we will try to predict the score on the basis of Y test and Y print as we have did earlier. Now for every time y test and y pred value being same, the accuracy will increase, and for every non-similar values the accuracy will decrease. So for this model we have got an accuracy of 91.11. So now let's go to our Visual Studios to see what we have learned till now. Okay, so now we have come to our Visual Studios. Now I'll quickly just run all the snippets and explain you the code one by one. So first we have imported pandas library here, and then we have read this iris data set. Now we have taken out the data information, all the entries, null values are present or not, column names, data types, memory usage, everything you'll get here. Now we have defined features and prediction class. So feature will have all the column names of the input data you will be taking from the user, and prediction class will have the output data that that the model will provide after processing the input data. Now we will store these values in x and y. So the feature class will store the value in x, and the prediction class will store the value in y. Now, using the train test split, we'll split the data of x and y into training and testing part. The train test split here is done into 70-30 ratio. That is 70% is the training data and 30% is the testing data. We can check by by printing out the shapes of training and testing data. Now from sklearn.neighbors, we will import nearest centroid and assign it to a classifier variable. Now we will fit this classifier with xtrain and ytrain, and then we will predict on the basis of this model the classifier on the basis of this model on x test data, and will store it in the ypred. Now for each x test value, if y test and ypred will have the same value in the accuracy score function, then the accuracy will decrease, and if not, the accuracy will decrease, and if it is, the accuracy will increase. And we will import this accuracy score from sklearn.matrix library. So this was it for nearest centroid. Now we will be moving forward with the conclusion, and we'll be concluding the video.